in the previous parts, we showed you how to come up with the equilibrium equations. So, and in the part right before this, we showed you how to use the matrices for each beam to come up with the moment and shear equations that we need to use the equilibrium equations. So, using equilibrium equation number 3, moment at d equals 0, we can plug in the values for length, and you come up with an equation in terms of theta d, theta c, and delta b. And just to simplify it a little easier, you can just bring it in terms of delta b. And then you move down to equilibrium equation number 1, moment at BA equals moment at BC. If you plug in the equation that we got for delta b, then this is the equation you get. You get an equation in terms of theta b, theta c, and theta d. Then you move on to equilibrium equation number 2. The moment at CB equals the moment, or the negative moment at CD. You plug in the equation for delta B again, and you get another equation in terms of theta B, theta C, and theta D. And then you move down to equilibrium equation number 4, and you get, so you plug in, again, the delta B value in terms of theta C and theta D, and then you get an equation using the shear in terms of theta B, theta C, and theta D.
I'm already rolling.
Okay, cool. So upon substituting those first 3 equilibrium equations and solving them simultaneously, you can either use your calculator, Excel solver, MathCAD, or you can do them by hand with some ugly math.
Or some magic.
Or you can try your hand at some magic. You'll find values for 3 of your unknowns. For theta B, you should get minus 3062 over EI. Theta C is minus 1811 over EI. Theta D is minus 9835 over EI. And you can take these 3 degrees of freedom and solve back in for your delta B, your displacement, using the third equation of equilibrium. So from there we find that the displacement of B, which is equal to displacement of C, is equal to minus 128,993 over EI. Now that we have all these unknowns solved for, you can go back through beam by beam and solve for your moments at each point. When you substitute them back in, you'll find that the moment about AB is 3,018 kip feet, BA is 1058 kip feet, and then so on and so forth. And for quick check, you notice that DC is equal to 0 like it was supposed to, so it all worked out pretty good.